So a couple things I want to cover. One thing, I was working with Jason and we saw a couple of things that I want to show that you can add to a class in order to do what's known as operator overriding in other languages, and so that you can make your class, if you're making one, respond to make it addressable as though it were a subscript, as though it were a list. And we're not going to really talk about that for too much, but we're going to go ahead and let's see, W. So we're on X. So say you're going to make a class. Wait. People call Ginner, what Paltrow that. And we're going to make a class called glob for whatever purposes. And it takes, it's got a constructor so that you can call it and create it. So down here in main, we can create one, right? G is equal to glob. What if for some purpose you wanted to be able to do things like this? Like that. And you wanted to be able to do this. To get this to work, you're going to have to add a method __ set item. And then in order to print out what you just said, like that, in order to print it back out, you're going to do get item. So anyways, self.I1 just for item 1, or how about I0, is equal to, who knows, none, and then self.I2 is equal to none. So we're going to create two variables. We're going to initialize them, and they're not going to have any good values in them. And so down here, we want to be able to do this to assign values. Well, why don't we try printing our object first? So we're going to need an str method so that we can do this. So define __str__ self, right? And then we're just going to return this formatted string version of self.I0, self.I1, end curly brace, end quote. Okay, so the rest of this isn't going to work, but the first of it, don't need all that blank space there. Let's comment these guys out, make sure that we get it up to this point. Glob object has no I1. Oh, that's because I called it I2 for some reason. All right, so there we go. Yeah, I know. I thought I commented that out. All right. Okay, so now we have a class that serves as, it's got a pair of pieces of information in it. Now we want to be able to assign values to them like this, just because that's the syntax that we want for whatever purposes. That's set item. To do allows setting with subscripts. And so what what set item needs well, that's not the clearest example. Sorry, I see a chat message. I almost never see the chat messages. Oh, you're saying my mic's not working. Oh, your mic's not working.
Yeah. Mine is it working now?
Yeah, I hear you now. Okay. All right. So set item takes two values, an index value, well, besides the self reference. Takes the index value and then the actual value, right? So when we call set item on it, we're going to get an index value of 0 and the actual value is Fred. So if the index is equal to 0, then let's set self.io I0 equal to that value. Elif index equals 1, then let's self.I1 equals value, and we could keep going, right, if we had more than one item we wanted to allow more than two items. Else.print. Whatever. So that should get these to work. These two lines of code should now work. I mean, they didn't crash, right? We could print ourselves out again after we assign them, and we'll see that we now have two pieces of data in there. Okay. Of course, we want them to be able to retrieve the data as well. So we're going to implement getItem. Now, getItem does have an index, but it doesn't have a value, right? All we need to find out is that index that they specified. So if the index is equal to 0, we're going to return self.I0. If the index is equal to 1, we're going to return self.I1. Else, I guess we'll just make ourselves return the none value. None is what you get if you call a function and it doesn't return anything. If you do this, define t, and you set x equal to 0, and then you don't do anything else, and then you say, you know, my value is equal to t, like that, and then you print my value out, it's going to say none. So it works just the same as if we did that. You don't even have to have that statement. It does it all by itself. So I could just leave that off, but I'm going to put it in there explicitly. All right, so now it will print out Fred. I mean, I guess we could make this print statement a little bit fancier, right? G subscript 0 equals end quote, comma, G subscript 0. And do the same for 1. Okay, so we assigned our two values. I thought I printed them out. Maybe I never did. I swear I had that there. Okay, so after we set those values, the pair of values becomes Fred and Bob. We print them out. And then if we wanted to add support for LEN, well, since this thing supports 2 pieces of data, we're just going to define it to return 2. That's all it has to do, is because we have 2 slots. So now it'll print 2 down here. And there we go, right? So we've kind of made our thing look like a list, right? We have now made it addressable via this format for whatever purposes. And these don't only have to be numbers, right? If you recall, if you have a dictionary, you can return things, you can specify other things in there if you want them to. So just as a reminder, if you had a dictionary and you're allowed to do things like this, right? Like that. So obviously the subscript doesn't have to be just an index. It could be any value. But that wouldn't work for this, right? Well, I mean, I guess it would, but it would just say index not found. So if we try to do something like that with our glob class, this is obviously not going to work because up here, we are specifying an index of a non-numeric value. So it's not going to equal 0. It's not going to equal 1. And so it's going to print, glob index not found index and complain about that. But if you wanted to make that work, you could do that. Yeah. Now 2 minutes on another topic. We've seen several different list types or data collection types. We've seen lists. We've seen dictionaries. And I think I've mentioned occasionally, maybe not, tuples. A tuple is a list that is immutable once created. And so lists are created with square braces. Dictionaries can be created like that. And tuples are created with parentheses. So we do this. XY coordinate is equal to, 1, 2. And then later on, you feel like changing one of those, you can do that, right? So now if we printed it out, it would say 2, 2. But if we put parentheses around them, then they become so-called immutable. Immutable meaning they cannot be mutated, meaning they cannot be changed. Yep. Object does not support item assignment. Okay, now we're just going to get goofy here and do this. I want you to try changing this item. I think we've only seen the try statement a couple times, but please try this. But if it fails, we're going to print an error message. Well, what kind of failure is this? When we ran it, it said type error. Let me make sure I get this exactly right. Try accept type error. Okay. So now when it runs, we're going to capture that error rather than crash, right? That's what try does. Please try this, but if it throws that exception, if it crashes with that runtime error, then it handles it. Now, previously when we did it, we just did that. That handles all errors, every error case. So whether it's a 1 divided by 0 or whatever, right? It'll say, oops, you can't assign values in a tuple, even though that's not what the problem is with this particular line of code. So even if this was correct, if this was a list, we're still going to catch this particular error. It's going to blow up and then say, oops, you can't assign values in a tuple, when that's not really the problem. Right? That's a different problem. So by specifying what kind of error we wanted to catch here, I really like the word catch, and a lot of languages use catch, but again, Python's always got to be one step to the left, and they put except. So now this is not going to handle the error, and it's going to say division, zero division error. Okay, well, that's a different problem. Right? And so now we are handling errors of both kinds. If this was declared as a tuple, so it does not assign it does not support index reassignment, we're going to get that one. But if, as we saw, if we had a list, instead it does that. Okay. So let's see, what have we covered so far? We've covered adding, and there's all sorts. So somebody had a really cute name for these functions that begin with double underscores, and I do not recall what it was. Can't come up with it. Anyways, there's all sorts of these functions that you can do to customize the behavior of these things. This is supporting something that C++ calls operator overriding, to where you're replacing the functionality of that. And you can override a lot of different things in a class. You can override the less than equal operator. You can override the add operator. Like that, so that you can use this syntax, take your object and add 10 to it. If you feel like doing that, you could. I'm not sure what we would do, to what purpose that we would possibly do with that. Let's just make it, if you pass in a plus sign, it'll add that number to both I0 and I1. So if they pass in a value, self.I0 gets increased by that value, and self.I1, that was supposed to be a 0, not an O, it's increased by 1. Now that's not going to work when these things are words, right? So let's change these so that instead we're passing in two values, like that. And then we're going to add hope I do this right. G plus 10 to it, and then print out G again. right? And so after that, it increased it by 10, right? Each one of those got increased by 10. So we made our data type now support the plus sign, and you can do all the math operators, right? Another kind of data is the set type. And if you define that and that and that, then how do you define a set? The only way I know to define a set is with the actual set function. Declare set Python. Oh, okay. So curly braces are for the set, and I don't know why it also works for dictionaries. Well, you can do it either way. So I guess that's implying that sets in dictionaries underneath it all are created the same way. So for dictionaries, let's just do it like that. Where did I have my dictionary example? Oh, I guess I deleted it. That was dumb. And then with set, you define it with the curly braces. So what is a set? We do this. I have students in one class consisting of Bob, Doug, and Eric. And then I have students in a second class consisting of Doug, Sue, and Tara. We want to see, we're going to get two different values. We're going to get the union of those classes. I am so sorry. The word class is kind of, all of a sudden, I don't like the word class just because we were actually talking about Java classes. And I just meant like classroom, right? But anyways, let's give them more generic names. So if you do set1.union set2, that combines. And if you don't know what a set is, that's totally fine. And if you do know what a set is, then that clicks. It just means that we're going to have something that is now equal to everything in this set plus everything in this set. So when we're done, we're going to have a set that's equal to Bob, Doug, Eric, Sue, and Tara. It's only going to have 5 elements in it. Why? Because one of them is repeated. And, the set will only contain the unique values. And then, like a Venn diagram, one of these things where something is one of these and one of these, and if that's true, then it's there. So in this example, right? So red fruit or apple and cherry, orange fruit or persimmon and tangerine, and the ones that are both are pepper and tomato. So anyways, this is an intersection right here. So if we do changed in my mind, I'm going to call that set 3, and then this is going to be set 4, which is set 1's intersection with set 2. So then we can print set 1 comma set 2. We could print set 3 comma set 4. And set 3 is the union of them, so it's going to be all of them, and set 4 is going to be only the ones that are in common with each other. And we only have one element that occurs in both sets. Right, so set 3 was equal to those 5 elements, and set 4 is the only one that those two things had in common. So the book talks about inheritance, I believe, when it's talking about classes. And by the way, I'm completely disgruntled with the books chapter on graphical user interfaces. I think that relying upon another class in order to build a graphical user interface, as they do in chapter 8 or whichever one it is silly, and that we should know how to use our own classes, the classes that TK Enter does. The class that they use, the class that they anyways, if you read the chapter and you look at a PowerPoint, you'll see that they did a little bit different. It'll look familiar, but they're relying upon another class in order to do it. One of the things that requires is to create what's known as a subclass. And that involves inheritance. Inheritance sets up what's known as an is-a relationship. We have been seeing has-a relationships right now. My class glob has two values. It has a I0 and it has a I1. Inheritance sets up an is-a relationship. Well, we've seen this where G is a glob, but what if glob is something else? So I'm going to create a class called cat or feline. Behold, a feline has been created. Now we're going to make another class. And what can felines do? Felines can purr. Not strictly true. I don't believe that all cat species purr, but just for the purposes, right? All right, now we're going to write a class called tiger, which is a feline. Now here we're going to have to add a line of code that you would not have to add in well, who cares whether you have to add it in other languages or not. We're going to make a call to feline's init method inside tiger's init method. And the syntax for this is going to look goofy. And it's just unfortunate. But you use a function called super. And the reason it's called super is because he is the so-called super class, not that he's more powerful. It's just that he is above this class and he is the subclass. Other programming disciplines call this the parent class and the child class. So anyways, we call super and we pass in the name of this class. Like that. And after that has been done, see, here's what bugs me about it is how in the world does this invoke this? I don't know, but it does. So watch this. If we say Tony is equal to a tiger, and then Tony.purr, it'll work. Well, how can he purr? Well, because Tony is a tiger, but a tiger is a feline, and the feline supports purring. So he picked up methods that are part of this class. So what could you do with that? Well, let's define a class called shape. And every shape, we don't even need an init method on this, but every shape is guaranteed to have a get area method. Even if it just returns 0, it's guaranteed to have a get area method. Now let's define two different types of shapes, like a square and a circle, because each one requires only one variable. A square radius, side length. How about just side? So this dot side is equal to side, so that we can do this, you know, SQ is equal to square with a side length of 10, right? That's what we want to do. And then we're going to say that every square is a shape. But we're going to replace the get area method with our own new get area method. This is called overriding. Even though he has this functionality, I guess I can go ahead and put the init there, just even though it's not doing anything. And then if we're going to do that, then this init needs to call this init's constructor, its init method. So super square self end parentheses dot init, whoops, dot underscore underscore init underscore underscore parentheses and parentheses. Well, anyways, now we have created this variable, and so if we want to return the area of a square, we can do so, right? So return this dot side times 2, right? I mean, multiplied by self squared, star star 2. And now a circle class. It's going to look almost the same, and forgive me for doing this, but it's just going to say, instead of side, it's going to say radius. And the formula for a circle is pi r squared. So return pi times this dot radius to the power of 2. Okay, so we create a square like that, and then we create a circle.
Is a square or are those supposed to be classes themselves?
You're correct. These are supposed to be classes. Thank you. Then x is equal to sq.getArea, and y is equal to circle.getArea, and print those out. And I called it this. And unfortunately, I called it this because in other languages, a great many other languages, you use this as this particular keyword rather than self. My mistake. Oh, come on. How many times did I do that?
There's one right underneath super too.
And it's not letting me type in corrections.
So the keyword there, super, is actually linking this class to the above class shape and then calling all the available definitions from shape. Is that am I correct?
Correct.
Okay.
Okay, finally. It wasn't letting me type for a moment.
And you don't have to specify which class we're actually linking it to.
We don't have to specify what?
Which class we're actually doing the linking to, because this one says super square comma self.
And this
should be.
This was actually supposed to be a circle. That was my entire goal of doing that.
Oh, okay, because it's circle comma circle parentheses shape. So that's where Python knows the parent class.
Yeah, and what I don't understand about the syntax is why we have to specify our own class name here. What super means is call my super classes init method. But apparently when we do that, we have to pass in a reference to our own class as well.
Yeah, because I thought we would pass in the reference to shape there. Because
you would have thought, exactly.
Yeah,
that would be my thought.
Yeah.
So get area, you always have to have a self parameter. My mistake. If it's a method, it needs a self parameter. I believe that to be true, unless. All right. So anyways, since both of these inherit from shape, they're both guaranteed to have all of the methods that a shape has. So they should all have a get area method, which we have replaced with a better one, and a display method. So what happens if we call this square.display or circle.display? So the shape has an area of, that would be our square because 10 times 10 is 100. And this shape has an area of that, which that would be the circle, right? Because pi r squared, 10 radius. So something interesting to note about that is that this shape is actually calling methods in its child classes, in its subclasses. What do I mean by that? When I call self.getArea, if all it was a shape and it had no other functionality, then getArea would always be 0. But we replaced getArea with a better, well, not with a better, but with one specific to the square and one specific to the squirrel. Circle. Where in the world did I come up with squirrel? So this function call, if the thing is a square, calls that. And if it is a circle, it calls that. And so that's a 5-minute introduction to inheritance. Inheritance means that you define a class, you specify it, your parent class, your superclass, and when you do that and invoke its constructor, then you get all the powers, all the methods and variables of that superclass as well as your current class. So a square has everything in it. And you can continue to do that if you want. We could make some kind of block class that was a square. And I don't really know. Actually, the reverse would be true, right? A square is kind of a rectangle, you know. But anyways, if we were going to be able to do something like that, you know, then you would just do that. And then when we call his superconstructor, it would call that superconstructor, which would call that superconstructor, and everything that a rectangle could do, it would have the same functions as a square and then whatever. So the term super is deceptive because it's not like the square has more powers. It's not like a shape as being the superclass. The one that's specified here has more power than the square class. It's not super duper. It's just in hierarchy, because he's actually got additional capabilities, right? He's got the ability to have a good one of these, and we could continue to add other functions. So it's the subclass that has the extra powers. It's just a super meaning above and sub meaning below. That's why I like the terms parent and child class better. So object-oriented programming is with inheritance is a topic much larger than just spending that 5-minute introduction on. But I wanted you to see it because I know that the book did talk about it, and in chapter 9 I just kind of glossed over it, thinking, okay, well, this isn't, you know, a 2,000 level course. I'm not going to talk about it, but then I felt guilty about skipping it. So I wanted you to see that. Wanted you to see that you can create a class which is another class and then has extra powers attached to it, right? Extra functions, extra methods that you attach to it. Alrighty, so I think out of the grab bag of Python things that I wanted to hit, I may have gotten them. So what I'm going to do now is we're going to take a hard left turn. I'm going to download an app called Textpad for Windows, just because I happen to know how to work with it in HTML. Except, there we go. Now, Textpad is an app that's installed on all the computers at campus, on campus. So if we were sitting in a classroom, we'd likely be using it. And it's certainly not the only text editor in the world. You can even just use Notepad. I'm just going to go ahead and grab this one because it has a nice little button that launches the file that you're currently editing in a browser. So it's shareware. You don't have to pay for it. You can install it, play with it for a day, and then undelete it. Undelete it and then remove it if you want. Wait, I think that this one may actually be a 32-bit version of Windows. So I'm going to grab the 32-bit version. Of course, I accept the terms without reading. That's right. So Textpad is a text file editor. And its claim to fame is that it has support for a whole bunch of different syntaxes in it. I don't know if it has Python. Let's go look. If I open up a Python file, or I make a new Python file, does it recognize the syntax for it? I'm going to have to increase the font size, and I will do that in just a second. Save my document as a PY file. Since it's a PY file, I'm going to change its save type to all files. I'm going to call it, you know, pytest.py, whatever. And I can't say that I see that it is color coding it. But if it was a Java file, if I did save as and said I wanted to make a Java file, then it would suddenly be color coded according to the Java rules. Now, Java doesn't have a DEF keyword, but it certainly has functions, just like Python does. And so that we can see it's done the syntax highlighting with the nice colors. But Textpad does that for a whole bunch of other languages and not just Python. Well, it'll certainly at least do it for the ones that are shown here, right? C, C++, HTML, that's good news. JavaScript, and I don't know what a clip library is. I don't know if you can get an add-on that would allow you to do Textpad editing of Python files with syntax highlighting or not. I don't really care because we have PyCharm and idle and stuff like that. But I do want to take advantage of its HTML context highlighting. So let's get the font visible. Well, that didn't change it. Didn't I change it? Well, anyways, if this is a Java file, I know that I could come down here and pick the Java font to make it bold as well, right? And so I'm going to do the same thing to HTML. So go and configure the settings for HTML. I went to preferences, document classes, Java, nope, HTML. Please use my font. I want it to be a nice thick 18 size font, bold faced. Okay, so there we go. I don't need my .java file anymore, but I am going to make an HTML file. I'm going to call it lecture x.html. All right, when you have an HTML file, if you click the little world icon here, it views it in the web browser. Now I could just save the file to a folder and then go and double click on that file. And if it had the HTML extension, it would view it in the web browser. So it's not like you gotta have Textpad or another text editor in order to create an HTML file. But this does have that option to launch it. And it has syntax highlighting. So I'm all for it. Okay, so let me just type for a second before I even oh, come on. Now, one mistake that I commonly make is I type all this and then I launch the Planet to view it in the web browser and I don't see my changes, and it's because I forget to save the document. If you look up in the title bar and you see an asterisk up here in the title bar, then it means that it has not been saved. And so I would need to save it. Click on the floppy disk. I just hit Control S, right? So it's saved now. I can launch it. And there we see my document. This is test. I guess I am Tarzan. I don't know how to use articles in my speech anymore instead of this is a test. So something you'll notice right away about HTML is that these things are coming in pairs, right? This is the opening of the block of HTML. This is the close of the block. This is the opening of the body. This is the close of the body. This is the opening of a paragraph of text. And this is the close. So what are these things? The things inside the angles are called tags. This is an HTML tag. And HTML, by the way, the idea of it predates the internet, actually, because you could organize data like this for other things, and not hypertext long predates the invention of the World Wide Web. And that's what HTTP hypertext, the HT stands for. So this is the opening tag, and this is the closing tag, which is the same thing, but with the slash there to indicate that it is closing. I don't see my HTML PowerPoints. Just a second. Now these are huge 100-page PowerPoints. So we're not going to step through them page by page. You have the option of doing that yourself. I'm just not going to do it in lecture. But this is worth talking about. I'm sitting here using my web browser on my phone or my computer or whatever, and I feel like viewing some data on the internet. And what do? I type in some URL up here at the top, hit enter, and it makes what's known as a page request. The page request contacts a server on the internet and asks it to fulfill that request. And in the olden days, what this thing would be a file name on the remote server. And so this part of the URL indicates the server name, and then the rest of this was a file name. And nowadays it can be anything. It doesn't have to be a file name. And because they have these web server programs going that accept this and parse it and, you know, return the desired whatever it was by running some program, and it's not going to be like physically opening a file and returning those bytes. But it could have been. This is like the oldest page I have been able to find myself. Something on a server called lumland.com, and it's got a file called index.html. And all it is a picture of this anime character called Lum from Urusei Yatsura. So anyways, this is the file name on that server, index.html. It's just a text file, just a pure text file. And so if I right click on it and I do view page source, I will see the text, right? Kind of familiar stuff, the HTML, and then the body. Not sure why body needed to be capitalized, right? And then center, because I want everything in this web page to be centered. And then whatever a div is, we'll talk about what a div is. BR stands for line break. And then an image. Well, that image apparently doesn't work because when we were viewing it, we saw this little broken link there. And then a table. And then there's another image. Okay, so we've already talked about the angle braces being used to define what are known as tags, but we see other words popping up now, like style and source. So if it's in angles like that, it's a tag, but if it's in the format of something equals, that's known as an attribute. And that's a modification. It tells something about that tag. This is an image, and here is the source of the image. This is supposed to be an image, so here's the source for that image. And oh, by the way, I need some additional information about it. I'm going to go ahead and say that this attribute style is equal to that, and that just indicates that I wanted that picture to fill up the page or something to that effect. Let's go back and look here. So what is happening? I make a request. My client, my browser makes a request. The web server opens that web page or otherwise fields a request to send back pure ASCII text, just plain old ASCII text, which my web browser then uses to construct a web page on the screen. Now, before the World Wide Web, the internet did exist for quite a, for a long time before that, but it was done all with text files, and you had text file browsers. And so you could open up, using a client. I don't remember if Gopher is the name of it or not, but you can go and you could view a hypertext document, except it would just be pure text. It would not have images and things in it. I'm making a point about it being a text file because this thing that I'm creating here is the same thing that gets sent to my web page. When I view this, and then I right click on it and do view source, view page source, I see my document, right? HTML body, just like that. So web pages are text files that contain HTML, which is hypertext markup language. What is hypertext markup language? It creates a document structure and the formatting. Now, the document structure is the semantic markup. It is the actual contents of the page, all of the text, and then the formatting for that text. And the tags, the markup tags, provide information about the content. So, various tags. HTML, start the document, start the header of the document. Now, I didn't put a head tag in mine. Script, enclose JavaScript functions. Title, specify the title of the web page. Well, I could do that, right? I don't know what to put in the head, so I'm going to open up the head. That sounds grisly. And then close the head. But in the head, I can probably specify the title. And the title of this is Lecture X. Now, you don't have to indent things. Unlike Python, indentation is optional, not mandatory. And if it's just something that can fit on a single line like that, typically what I do is just do it like this. Put it all on one line like that. Okay. And then that page of the PowerPoint, mentions the H1 tag. There's also H2 and H3, which are just smaller forms of headers. Save it, Control S, launch it. Right. So there's my header. There's my subheader. That's my text. And the title of my document is Lecture X. Now, back in olden days, what you would do is you would embed attributes in your tags in order to communicate and to control the formatting of it. Like if I wanted this font here to be red, I could do that, I believe. That may not be how you do it, because you're not supposed to do it like this anymore. There are things that are known as deprecated tags. Deprecated tags are tags that still work, but you shouldn't use them anymore. Why? Because they've been replaced by more flexible ways of doing it. HTML1 had lots of formatting tags in it. Well, see, that's not how you do it.
I think you forgot to save it.
Yeah, that's possible. Well, see, that's failing. I'm trying to demonstrate something to you that in a way that I shouldn't be doing it. And so why am I spending multiple time on it? It got me. But then there are things known as styles or style attributes, which is the modern way to do it. And when I say modern, like in the past 10, 15 years, you know, since 2000 or whatever. And it's where you use this word, style, and you make an attribute for your paragraph tag, and you specify information, formatting information about this tag that you're using. And in this particular case, I want red text. That I did not mean to do. And now my text is red, right? And I can chain a whole bunch of different things inside the style attribute. So why did they like that better than coming up with inline tags for controlling it? The idea was to completely divorce the appearance of the document from the formatting of the document. And you can create what are known as cascading style sheets, to where all the styles are specified somewhere else, and then you just reference the style here and it picks up that style. And then you can make that particular style dependent upon which, you know, operating system you're reviewing it under, or whether it was supposed to be a mobile device or, you know, a desktop computer or whatever. It's too bad that that color tag that I tried to get to show y'all did not work. I wish I even remembered it. Would have been a good description. Let's go back over here. So we have the body, we have the image tag. Well, the image tag, as mentioned, just shows us the path to, just serves up a file. Now, that file could be in the same directory as our HTML file, or it could be a URL, right? It could be a path to a file on the internet. Let's go and find some file on the internet. Puppy. So I'm just going to open up and find a picture of a dog. Go away. Right click and do copy image address. I just want the address of that image so that I can come to my text editor and do img src equals quote, quote, close angle, and then inside the src, I paste. And oh boy, that's nice and long. Staring at this, I wonder if I could get rid of this resize equals 980 business and just end it at .jpeg. Yeah, I'm going to do that. Okay. Save it, run it, and there's my dog. All right, now that is too large. I want to control that thing's size. I will do that with style attributes. So when I'm specifying my image, you can do it in two ways. You can do it with the HTML attributes, which are deprecated, or you could use the CSS width and height properties to define the size of the image. And I'm going to go ahead and do that. I don't know why that wasn't right there, but if I come in and I say image style equals, and then I put a pair of quotes, and then width colon 400 semicolon height colon 800 semicolon. Now that's going to be ridiculous, right? The dog is not going to be recognizable. It's going to be a very stretched out image. Notice that the attributes, which are HTML attributes, are specified by attribute name and the equal sign. Style attributes are assigned with an attribute name followed by a colon followed by a value and separated by semicolons. Yeah, so there's our very tall, skinny puppy. Hey, that's the name of a Gothic rock group, Skinny Puppy. Let's make the height of it like 300 and see if that looks a little bit better. Yeah, like that. Okay. What other attributes are there for the image tag? Image tag attributes. I think that's just what I was looking at. Alt. Alt specifies alternate text for the image, and that's for screen readers. You know, somebody who is using screen reader software, it describes the images on the screen so that you might be able to, you know, use that in conjunction, you know, for the visually impaired, so that as you moved your mouse over an image or something like that, it would be able to speak what that was. Cross origin, height, is map. That would be so that you could make an image and then it would be responsive to clicks, and clicks in certain areas would map to function calls to certain routines to be called. So that if you clicked on the top part of the image, it would do something, and if you clicked on the bottom, it would do something else. That's very, very antiquated. Long description specifies a detailed refer policy, SRC, source set, use map, and width. Okay, so anyways, that's enough about the image tag. I think we understand that, except I also wanted to demonstrate that the image could be saved locally. So let's go find a kitten. So I'm going to right click on the kitten and do save as. I'm not sure where I'm saving my text document. Mac home documents. Okay. So kitten.jpg. Saving it there. In the same directory as my lecture, right? So if I refer to that image, image source equals quote kitten.jpg end quote in parentheses, I should see that image as well. Yep, huge cat. So I'm going to make it the same size as the other one. And when I do that, if you specify only one attribute and not the other of its height and its width, it will scale the image appropriately. So I'm just going to say that this guy is the same width and then let it figure out the height. It will make it proportional if I do not override it by specifying both. So this one's also 400 pixels wide. Continue my evaluation. Alrighty. So there we go. We have two images of the same width. Well, they're located side by side. Is that what I wanted? It's fine with me, but if I was going to do that, I probably would have made them the same height. What if I wanted them to be under each other? A couple of things you could do. One is that you could just separate them with a line break, right? Just like hitting return. There we go, right? Why do I have an S down here at the bottom? Oh, because of that. Now you can break up your block into divisions. We could say that I want all of this stuff to be in one area. And then I'm going to close that. And then I want my pictures to be in a separate area. And so the style for this division is going to be background color. How do you set the background color of a division? Background dash color. Background dash color colon black, end quote, or semicolon, end quote. So this section has a white background, or it has a default that it picked up, and this one has a black background. If I go back to that web page I was just looking at, this is an example of cascading style sheets here, because in the head tag there is a style tag, and the style says that, oh, the header is supposed to have a background color of green. Let's play with that. Let's add a style to our. So up here in the head, style, and you define what style you're overriding. I'm overriding the style for header 1 tag. And the background, well, let's just say color, right? The color of header 1 is supposed to be purple. Now, apparently I did something wrong because it's not displaying anything at all. What you will find if you do this for any length of time at all is that it is incredibly frustrating because you don't get syntax errors. It just fails to load. So I did not close my style tag. I do not think that that's actually the problem. Let's look more carefully at the example over here. Oh, doesn't look so bad. Yeah, that was it. All right. And so now purple is, excuse me, the header is purple. I have controlled what it looked like by coming up here and defining style tags for it, which is divorcing the appearance of this data from its contents, right? We have some text, and we're defining the text down here, the data, and then we're starting to control the formatting of the data up here in the style section. And this style section could be saved in a separate file and referenced so that the same document could be formatted with different styles depending upon your different needs. So the same data can be, reflected in different ways depending upon the different needs. It's going to be about time to wrap up. So tags must have closing tags. Not strictly true. There are a couple of tags that are known as self-closing tags. We've used 2 of them so far. I don't have a closing tag for image, right? I declared my image and then that's it. I didn't need to do anything. There was no reason to add this. Didn't need to do that. I don't think that that would generate an error. Here was the other one, the line break. Now, there's the convention or the specification that says if you're using a self-closing tag and you want to indicate that it's a self-closing tag, you just put a slash before the greater than. What that means is that here comes this tag, and oh, don't bother looking for a closing tag. You don't have to have one. Now that is strictly correct. It works if you leave it out. It's better to do it that way so that it passes syntax validation, because you can upload your web pages to, syntax validators and, it'll report errors and stuff like that. Then you would not get any warnings about unclosed tags if we had that there. Otherwise, that won't modify its behavior, right? We're going to stop there. Yes, I think we are. It's so tempting to keep going. All right, why don't we stop here? What we're going to come up upon next time is the ability to add code to the web page. And we will do that through script tags and by adding extra attributes to the elements that are down here, so that we can create buttons. And then if you click on that button, it invokes the JavaScript that we're going to assign to it. All right, that's enough. I'm not going to assign homework. I still want people to be working on the projects. So why don't we just slow to a halt here.